Okay, in this video we're going to use the shortcut formula for finding f prime of x. And f prime of x is used to find the slope of the tangent line, like the instantaneous rate of change, or also for velocity at a specific time. So if you have a function ax to the b, then your f prime of x is found this way: ab x to the b minus 1. In other words, you take that exponent, whatever it is, you multiply it times the coefficient, and you decrease that exponent by 1. Okay, you multiply the coefficient by the exponent and reduce the exponent by 1. So let's do one. In an earlier example, example 6c, this function we had right here, f of t equals negative 16t squared plus 400. What is f prime of t? Well, we bring that exponent down in front. 2 times negative 16 is negative 32, and then we reduce that exponent by 1. Just subtract 1 off of this exponent. 2 minus 1 is 1. So that's negative 32t to the first power right there. Now what about this 400? Well, this goes away. Why? Because it's the same as 400 times x to the 0 power. The 0 comes down in front, and 0 times 400 is 0. So you just get negative 32t. That would be the f prime. Now if it says, now this one was for height at a particular time, and this now will tell you the speed at a particular time. If it says what's the speed in 5 seconds, you would just do this, what we just did, and then put 5 in for the t right here. Negative 32 times 5 is negative 160. So the speed would be 160 feet per second going downwards. That's what the negative means right there. Okay, here's some ones to practice on. Find the equation used to find the slope of the tangent line. In other words, find f prime of x for the following. First one is negative 3x squared. Well, all you do is take the 2 down in front and multiply it together. You'll get negative 6x and reduce that by 1. So you just get negative 6x. Here's one. Gives you a whole bunch of pieces. So on this piece, bring the 3 down. 3 times 6 is 18x. Reduce that by 1. 18x squared then. Bring the 2 down. 4 times 2 is 8. So it'll be minus 8x. Reduce that by 1. It'll be just 8x minus 8x. And then right here, that's 3x to the first. Bring the 1 down. 3 times 1 is 3. X to the what? 0 power. X to the 0 power is out of there then. It's really just 1, and 1 times that minus 3 is just minus 3, and again this is like x to the 0, bring the 0 down, 0 times 4 is 0. So the constant is going to be gone. So in general, you can tell this real fast. When you do the f prime, it's actually called the derivative of this thing. Derivatives of constants are 0. Derivative of linear terms like this is just the coefficient, and when you go up higher powers, you actually have to do that stuff. Bring that down, it'll be negative 8x. Bring this down, it will be 18x squared, because you knock it down 1 power. Okay, here's an example. It says for this function right here, get the velocity when the object hits the ground, is what we're supposed to do. Okay, the first thing you need to do with this is find out when this thing hits the ground. Well, when it hits the ground, the height is 0, so you're just solving this quadratic, setting it equal to 0, and you can do that easily on the quadratic sheet. I'll just go there and type in my coefficients of negative 16. I think it was 50, and let me check the coefficients one more time. Negative 16, 50, and 400. So let's see this one more time. And 400. Now when does this thing hit the ground? Well, that would be actually the x-intercept, where you put 0 in for y. Either way, get the same answers here as we have up here. And the only one that makes sense is this 6.801 seconds. So it hits the ground in 6.801 seconds. Now, if you want to find the speed when it hits the ground, you have to plug that time of 6.801 seconds into the velocity equation. Now, the velocity equation is from taking that h prime thing. Okay, so do that. When you do the h prime thing, that's what we're just practicing up here. Bring the 2 down, you get negative 32t. Subtract 1 off the 2 to get 1, so it's just negative 32t to the first power. And right here, the derivative of a linear term is just this 50 right here, because this is t to the first. 1 times 50 is 50, t to the 0, so just 50. Now plug in that 6.801 into this. You could do that on the linear sheet, or you do it on a calculator. Take negative 32 times 6.801 plus 50, and you get negative 167.63. and that will do it right there. There's also a little thing on the Excel sheet. If you scroll down to the bottom, it gives you the slope of the tangent line, your f prime of x right here, negative 32x plus 50, and you can plug in a x value right there. Like if you wanted to know what it was, and what was it, 6.801 seconds, 801 seconds, you get that the speed is negative 167.63. And that's what we got right there. So I think that would do it. That saves a lot of time and is much faster than doing it the long way, in which some of the other videos show up here, in which you're doing the difference quotient. That difference quotient is important for those people going on to business calculus or actual calculus. You'll have to do it the long way in those courses, so you'll need to know it that way for business calculus. But for this course, we can just do it by the shorthand method that was shown right here, using this shorthand method of finding the f prime of x. And I'll stop right there.